Welcome to this explainer. Look, today we're doing something a bit different. We're stepping into what is essentially an elite masterclass on the deep biological mysteries of sleep, chronobiology, and those invisible forces that are literally dictating your physical and mental health. Here's the truth. The modern American lifestyle has us fundamentally disconnected from our evolutionary light environment. We're going to go really deep into the interconnected systems of the human body today, exploring how the exact light you're sitting in right now is fundamentally altering your brain health, your cognitive performance, and even the speed at which you age. If you want to optimize your capacity for deep work, preserve your daily micro-mental health, and build true, lasting longevity, well, it all starts with understanding the hidden clock operating right behind your eyes.
We have all been sold the exact same modern wellness belief, haven't we? The idea that the blue light emitting from our phones, our tablets, and our monitors is the primary destroyer of our deep sleep. So we buy those expensive special glasses, we download the color-shifting apps, and yet we still lie awake staring at the ceiling at midnight. But what if the actual science points in a completely different direction? What if the physical spectrum of light coming from your screen is really only a tiny fraction of the real story? To actually understand why our sleep architectures are so profoundly disrupted today, we have to look at this jarring number, 90%. Think about that for a second. For over 10,000 generations, human beings adapted to intense environmental contrasts. We're talking brilliant, bright sun during the day and absolute pitch-black darkness at night. But today, the average American spends roughly 90% of their time indoors. We transition from cubicles to cars to couches, living our lives under this flat, artificial electric light that is literally 100 times dimmer than daylight, yet 100 times brighter than moonlight. This massive evolutionary mismatch is what's driving a silent epidemic of chronic stress, metabolic disruption, and cognitive decline. So let's unpack how this actually works in part one, the anatomy of the inner clock. We've got to talk about a discovery that completely changed how we think about human vision. For a century and a half, science believed our eyes only used rods and cones to see images. That was it. But in the late 90s, researchers found a third, completely hidden class of photoreceptors. They're called IPRGCs, and they make up just 1 to 3% of the neurons in your retina. And here is the crazy part. They don't form visual images at all. Instead, they act as an autonomous chemical light meter, constantly measuring the ambient light around you to synchronize your entire biological clock with the outside world. And the way these secret cells pull this off is through a highly unique photopigment called melanopsin. Melanopsin is fundamentally different from the pigments in our visual rods and cones. It is exceptionally sensitive to short wavelength blue light, peaking right around 480 nanometers. When that specific wavelength of blue light hits your eye, the melanopsin triggers this massive depolarizing cascade. It completely bypasses your visual cortex and sends a direct electrical signal straight into the deepest, oldest parts of your brain. This is the raw biological mechanism that tells your nervous system, hey, it's daytime, time to go. And these melanopsin-loaded cells project directly to two totally different areas of the brain, which brilliantly illustrates how light dictates our nervous system. When they detect blue light, they signal the SCN, that's the master clock in your hypothalamus. This pathway drives sympathetic arousal. It spikes your cortisol, suppresses your melatonin, and keeps you hyper-alert. But there is a second pathway connecting to the VLPO, which is essentially your brain's sleep switch. Interestingly enough, cells connected to the VLPO are heavily influenced by green light, which actively promotes sleep onset. So blue light equals SCN-driven stress. Green light engages the VLPO for deep recovery. Your daily micro-mental health relies entirely on keeping this incredibly delicate balance. Which brings us to a major modern dilemma in part two, the screen time paradox. Okay, if you are wearing a pair of those trendy blue light blocking glasses right now, you really need to hear this. Recent systematic reviews, including gold standard Cochrane reviews and actigraphic crossover trials, put these glasses to the test. And by the way, actigraphic means they measured objective physical sleep architecture, not just asking people how they felt they slept. The actual results? Compared to clear lenses, blue light blocking glasses offer almost zero objective improvement. There's no statistically significant difference in how fast you fall asleep, your total sleep time, or how often you wake up in the middle of the night. For the vast majority of people, just buying the glasses simply doesn't fix the underlying biology. This totally upends what we've been told, and it leads chronobiologists to the absolute most crucial debate defining modern sleep science right now. Think about it. Does evening sleep disruption stem primarily from the physical spectrum of the light hitting your eye, or does it actually stem from the psychological stimulation, the cognitive hyperarousal associated with doom-scrolling social media, getting into internet arguments, or answering rapid-fire work messages at 10 p.m.?
When you look at the real-world data, the contrast is stark. Yes, in highly controlled lab settings, staring at a light-emitting ebook for hours in a dim room does delay the body's natural melatonin release by about an hour and a half. But out in the real world, systematic reviews show that general, passive evening screen use only delays sleep onset by an average of about 10 minutes. But look what happens when you introduce highly interactive behavior. Late-night interactive gaming or firing off stressful emails pushes that sleep delay significantly further, heavily disrupting your sleep architecture. The light is a factor, for sure, but it's the active, engaged nature of the device that is truly sabotaging your rest. The absolute crucial takeaway here is this. Cognitive hyperarousal completely overrides your homeostatic sleep pressure. When you read a stressful email from your boss at 11 p.m., your brain triggers an active sympathetic nervous system response. You release cortisol. You enter a state of high psychological arousal. A pair of amber-tinted glasses cannot fix a brain that is actively stressed and engaged. Your micro-mental health, your sleep optimization, and your capacity for deep work the very next morning are completely intertwined here. You simply cannot biohack your way out of behavioral overstimulation. Now, how does this interconnected system change over our lives? Let's explore part 3, lifespan, light, and aging. Our circadian rhythm undergoes a profound biological journey as we age. Newborns have highly erratic sleep simply because their circadian networks haven't fully developed yet. But look at teenagers. They experience a massive biological phase delay. Their melatonin physically does not rise until 10 or 11 p.m. They are literally wired by biology to stay up late. Moving into adulthood, this stabilizes into a more standard 24-hour rhythm. But as we reach older adulthood, the clock experiences a phase advance. It shifts earlier, which is exactly why older adults naturally wake up at dawn. And this shifting internal clock is paired with dramatic physical changes in the eye itself. Just contrast the adolescent eye with the aging eye. A teenager's optical lens is crystal clear. It lets in maximum light, making them hypersensitive to evening screens, which aggressively delays their already late sleep cycle. But as a totally natural part of healthy aging, the lens of the eye thickens and naturally begins to yellow over the decades. This creates what we call the fascinating paradox of the aging eye. That natural yellowing actually acts as a built-in blue light filter, protecting older adults from evening screen light, which sounds great, right? But there is a severe downside. Because the lens is yellow and thicker and the pupil becomes physically smaller, a condition called senile miosis, the brain is essentially starved of the bright daytime blue light it desperately needs to set the circadian clock. This weak signal leads to irregular sleep-wake rhythms, chronic daytime napping, and even cognitive decline. In the context of longevity, disrupted circadian rhythms aren't just a sleep issue anymore. They are now considered one of the earliest biological predictors of physical frailty and accelerated aging. So how do we take control of all this? Let's get into part 4, the practical framework. The single most powerful health tool you have isn't a fancy supplement you buy. It's something called the daytime light buffer. Research clearly shows that if you expose your eyes to bright daytime light, specifically measuring over 500 lux, you build up a massive physiological buffer. This robust daytime light entrains your master clock so powerfully that it almost completely eliminates the melatonin-suppressing effects of normal evening screen use. If you want to sleep deeply at night and sustain real cognitive endurance during the day, you have to aggressively seek out light while the sun is up. It's non-negotiable. So here is your biologically sound, evidence-based protocol for true circadian health. Step 1, maximize your outdoor daytime light exposure, especially in the morning, to build that buffer. Step 2, after sunset, physically shift your environment to dim, warm light. Think small lamps instead of bright overhead LEDs. And step 3, recognize that cognitive hyperarousal is your biggest enemy here. You absolutely must cease interactive, high-stress screen use an hour before bed. Passive reading or watching a calm show, that's biologically fine. But checking work emails or scrolling through a stressful newsfeed is going to trigger a sympathetic arousal cascade that completely destroys your deep sleep. I really want to leave you with a final thought to reflect on today. Your internal clock dictates your stress resilience, your cognitive focus, and even your cellular aging. Every single time you flip a switch or open a laptop, you are directly programming the deep, invisible architecture of your brain. So ask yourself, are you managing your light or is your light managing you? Take control of your environment and you take control of your health. Thanks for joining me on this explainer.